Student, in this video I will teach you how to find unpaired electron, how to find unpaired electron, how to calculate unpaired electron, unpaired electron. So mostly the questions for this unpaired electron is asked from 3D series. So you have to remember this 3D series, particularly scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So maximum questions are seen from this series only. So let me explain you. So like scandium, the atomic number of scandium is 21. The atomic number of scandium is 21. So its configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. So it is 21. So 10, 20, 21. So when they ask you to remove electron from scandium, suppose scandium plus, you have to remove electron from 4s. You have to remove electron from 4s because 4s is outermost here. Maybe the energy of 4s is less than 3d, but you have to remove from 4s, and then after removing all the electron from 4s, then only you can remove from 3d. So scandium plus will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d1. So it has two unpaired electrons, one in s and one in d. Suppose scandium 2 plus, then you can write for this argon, and it will be 4s will be removed, so it will be 3d1. So it has one unpaired electron. Suppose they ask you for scandium 3 plus. So scandium 3 plus means both 4s2 and 3d1 will be removed, so it will be simply argon. So scandium 3 plus will have no unpaired electron. Scandium 3 plus will have no unpaired electron. Suppose they ask you for titanium. So titanium configuration will be argon. It is 22. So argon 4s2, 3d2. So it has 2 electron in 4s and 2 electron in 3d. So what you will do, if titanium 2 plus is asked, then you can write argon 4s, both the electron will be removed, so it will be 3d2. So it will have 2 unpaired electron because d has 2 electrons, so 2 are unpaired. Suppose they ask you titanium 3 plus. 3 plus means argon 3d1, so it has 1 unpaired electron. So here it has 2 unpaired electron, and here it has 1 unpaired electron. Suppose they ask you titanium 4 plus, then both these 4s and 3d will be removed, so it has only argon, so there is 0 unpaired electron. So titanium 4 plus will have no unpaired electron. Titanium 4 plus will have no unpaired electron, and titanium will have 2 unpaired electron. Titanium 2 plus will have 2 unpaired electron. Titanium 3 plus will have 1 unpaired, but titanium 4 plus will have no unpaired electron. Now coming to vanadium. Vanadium atomic number is 23, so its configuration is argon 4s2, 3d3. So if they ask you write vanadium 2 plus, then its configuration will be argon 3d3, because both 4s electron will be removed, so it has 3 unpaired electron, 3 unpaired electron. Suppose they ask you vanadium 3 plus, then its configuration will be argon 3d2, that means it will have 2 unpaired electrons. Suppose they ask you vanadium 4 plus, then it will be argon 3d1, so it will have 1 unpaired electron. Vanadium 5 plus will have argon configuration, it will have no unpaired electron. It will have no unpaired electron. Now coming to chromium. Chromium has a special configuration of 4s1, 3d5. Suppose they ask you to find chromium 3 plus. So it will be argon. So chromium is 24, 24 minus 3 is 21, so 3d3. So it will have 3 unpaired electron. It will have 3 unpaired electron. Keep in mind that this type of stable configuration or exceptional configuration is only valid for atoms, not for ions. Now suppose chromium 6 plus they ask you. 6 plus means 4s1 and 3d5 all will be removed, so it will have an argon configuration and there will be 0 unpaired electron. So maximum most stable state of chromium is 3 plus and 6 plus only. Now coming to iron. Iron configuration is argon 4s2 3d6. So iron most stable state are plus 2 and plus 3. So generally question will be asked for plus 2 and plus 3 and which is more stable. So plus 2 means 2 electron has been removed, so this will be removed from 4s, so it will be argon 3d6. So it will have 4 unpaired electron. Keep in mind student that D can have maximum of 5 unpaired when it is D5, but when it is D6 then it will have only 4 unpaired electron. So first electron, second, third, fourth, fifth, sixth. So this has 4 unpaired electrons, so it has 4 unpaired electrons. Now coming to Fe3 plus, it will be argon 3d5. 3d5 has 5 unpaired electron. 5 unpaired electron. This way you can find out the number of unpaired electron for different elements of 3D series. Now I am giving you a trick which will help you to solve the questions. The trick is simple. Just remember this atomic number 21, titanium 22, vanadium 23, chromium 24, manganese 25. Suppose they ask you what is the unpaired electron in Mn2 plus. Suppose Mn2 plus. So manganese is 25. So you have to subtract 2 from it. 25 minus 2 is 23. 23 you have to subtract 18 of argon. So it will be 5. So it will be 3d5. So it will have 5 unpaired electrons. It will have 5 unpaired electrons. Suppose they ask you, suppose chromium 3 plus. So chromium is 24. 24 minus 3 is 21. 21 minus 18 is 3. So it is 3d3. That means it has 3 unpaired electrons. So this trick can be used for 3D series easily and you can solve. Like suppose Zn2 plus they ask. Zinc is 30. 30 minus 2 is 28. 28 minus 18 is 10. So it has no unpaired electron. Zinc 2 plus has 0 unpaired electron. In the atomic form as well as in the ionic form, zinc don't have any unpaired electron. That's why zinc is regarded as, along with zinc, cadmium and mercury, they are regarded as pseudo transition element. Coming to vanadium, vanadium 3 plus. So vanadium is 23, 23 minus 3 is 20, 20 minus 18 is 2, so it has 2 unpaired electrons. So this way you can find out. Suppose copper plus. So copper is 29, 29 minus 1 is 28, 28 minus 18 is 10, so that means it has 0 unpaired electron. Copper plus has 0 unpaired electron. Suppose they ask you for copper 2 plus. Copper 2 plus they ask you, then copper is 29, 29 minus 2 is 27, 27 minus 8 is 9, 9 means 1 unpaired. So copper 2 plus has 1 unpaired electron. So this way you can find out the number of unpaired electron for 3D series. Thanks for watching student. This is Sandeep sir signing off.